condition for maximum deviation. Chala important. Condition for maximum deviation. Okay now. So this is the face of a prism. So face of a prism, and this is the incident ray. As it is incident ray, and this is a normal. This refracts, as this is a rarer and this is rarer, because rarer to denser, when you draw the normal, so always it bends towards the normal. It always bends towards the normal. Again there is a normal, and this is a denser and this is rarer. It bends, so denser to rarer, again it bends away from the normal. This is the basic thing you are seeing. But what is the meaning of maximum deviation? So when the incident ray is produced forward, and an emergent ray is getting backwards, and the angle between the incoming ray, that is incident ray, and angle angle between the incident ray and emergent ray is called deviation. Is called angle of deviation. But what they are asking here is maximum deviation. So when can be this be the maximum deviation? So we know that the maximum deviation, where can you see the largest change? See that this is the angle of deviation. Now if I turn on and tilt it more and more, if I do the deviation over on this line, that means the incident ray should normally incidented on the prism. When it is being incident normally, you will see the change between the emergent ray and the incident ray and emergent ray is maximum. After this, you cannot have the production of the I. That means I should be equal to 90 degrees. I should be equal to 90 degrees. That means we have the formula that delta is equal to angle of incidence plus emergence minus A. Here, what is the I value here? Delta is equal to 90 plus E minus A. So this is the condition for getting a maximum deviation for a prism. Okay? Condition for a maximum deviation in a prism. Okay, clear? Okay now? Are we clear? There is another condition also you can get for a maximum deviation, but I have first discussed about the incident ray. Okay, what should be the incident ray angle? Should be 90 degrees. That means deviation, how much you are getting the maximum value? Delta is equal to I plus E minus A. Therefore, delta is equal to 9 plus E minus A. Clear? This is the angle of incidence. I'm not changing this incident ray, but this is a refraction. This has been reflected, but the emergent ray is coming out. So there is a grazing of emergence, Okay, and this is the R1, and I do produce this normal. They meet here, and here the angle of emergence with the normal is 90 degrees. Here the, so when can you see that grazing of emergence? You can say that whenever the incident angle is been strike, and that I will be equal to theta c if the refraction will be equal to 90 degrees, or else this is the condition you will see. So if it means grazing, means the refraction R2, this is R1 and this is R2, this is angle. So and this is R equal to I theta c. Okay, I is equal to theta c. Okay, fine. Now when this R2 will be equal to IC, R2 will be equal to IC. If RT equal to IC only, you will get the grazing of the, because for this surface side, R2 will be acting as an incident, right? So R2 will be equal to critical angle. That's why you are getting a grazing of emergence. Okay, clear? Now, what you are going to do here? Now, what will be R1? Now we know that R1 plus R2 is equal to A. Therefore, we can write that R1 is equal to A minus R2. Therefore, R1 is equal to A minus IC. We have the formula that is sine IC is equal sine C, that is a critical angle, that is 1 by U. And to find out the cos C is what, under root of 1 minus sine square C, that is cos C is equal to under root of 1 minus 1 by mu square. So 1 by mu square. So you get cos C is equal to mu square minus 1 by mu. Okay, this is the mu square. So this is the value you are getting. Now, latest, we copy it down till here. Okay. Now you have the from the Snell's law. Next, what we are going to do, that sine we have from the Snell's law from the first side, it is sine I is equal to sine R is equal to mu. Sine I by sine R is equal to mu. Okay. Now sine I by sine R is equal to mu. We have that what you say here, sine I, this is sine I1, this is sine I1. So sine I1 is equal to mu times of sine R1. So we have sine I1 is equal to mu times of sine R1. We have the relation that is A minus IC, A minus IC. So sine I1 is equal to mu times of sine. So sine of A minus B is what? A minus B is what? We have the formula that is sine A cos IC minus cos A into sine IC. This is the general, because sine of A minus B is what? Sine A cos B minus sine B cos A. That is the formula I have applied here. Next, afterwards, introduce the formula that is sine I1, that is sine I1, that is equal to mu into sine A, sine A. Cos IC is what? Under root of mu square minus 1 by mu minus cos A into 1 by mu. So you get here sine I1 is equal to mu get cancelled, mu get cancelled. You have sine A is equal sine A into under root of mu square minus 1 minus cos A. So I1 is equal to under root sine inverse of sine A into mu square minus 1 minus cos A. So this is the, you will get. Clear? Condition for no emergence. No emergence. Condition for no emergence. Okay, now this is prism. Okay, now this is a prism, and this has been an incident ray, and this is the normal if SP reflected, and you will see there is no grazing. Grazing emergence means it will have a total internal reflection. When can this happen? That incident ray striking at the second side surface should be greater than the critical angle. Should be greater than the means this side you are having R1 and this side you are having R2. That means here the R2 condition is valid. R2 is greater than the IC. Okay, right? So to have that R2 is greater than R2, for suppose in order to not have the what do you say, no grazing of the emergence, I will imagine that R2 is minimum. R2 is minimum. I mean, this is R2 is minimum. Definitely, this R1 one side angle will be greater. R1 will be maximum. R1 maximum means R1 when this is maximum. Definitely, I incident angle also will be maximum. That means I1 will be maximum. That means incident angle, whatever when can be the angle of incidence will be greater. This is only possible that incident angle will be equal to 90 degrees. Then only you can choose this because the maximum angle of sine is what 90 degrees. That is why I chose I is equal to 90 degrees. That means we can write that formula is sine I by sine R is equal to what is a refractive index, that is I'll write here mu. Now sine I is what 90, sine 90 is 1 by sine R. We can write that mu refractive index is according to the critical angle, that is 1 by sine C. So sine I1, this is R1, and R1, this is sine IC. This is a critical angle. So when the numerators denominators are equal and numerators are equal, you can also write sine R1 is equal to sine IC. So neglect those trigonometry terms, you get R1 is equal to IC. R1 is equal to IC, you get. Now, we already confirmed that what is that R2 is greater than IC. So R2 is greater than IC. I add both sides R1, R1 plus R2, that is greater than R1 plus IC. So we have R1 plus R2 is what? A. We know that A is equal to, according to mean deviation, R1 plus R2 we got. So A is greater than R1 plus. So R1 can be written as IC plus IC. That is A is equal to 2IC. So IC is equal to A by 2. So means it should be angle of the prism. We should definitely make half in order to get total internal reflection in the prism A by 2, which is greater than IC. For this condition only it will be okay. Now, what will I do here? IC can be written as A by 2 under root of sine inverse of 1 by mu. So sine inverse, because IC, what is the formula? Sine inverse of 1 by mu. You know now, sine C is equal to 1 by mu. C is equal to what? Sine inverse of 1 by mu. The basic formula I have applied here. Now sine A by 2, it will become sine A by 2 is greater than 1 by mu. So mu will be going to that side and 1 by sine A by 2 you are getting. So 1 by sine A by 2 is what? Mu is greater than cosecant A by 2. This is the basic condition. Clear? For condition for no emergence means what should be the refractive index should be greater than the cosecant A by 2. Sine I by sine R. Okay, this is the basic formula. I and for small angles, sine terms will
ఎందుకు
sine terms neglect neglect. Okay, that is mu is equal to, you can write it as sine I1 by sine R1 is equal to sine I2 is equal to sine R2. So these are the differential units, whatever will be constant. Now what you can, for sine terms you can calculate. So mu is equal to I1 by R1, that is equal to I2 by R2. Therefore I1 is equal to mu times of R1 and I2 is equal to mu times of R2. This is the basic condition you are having. Now what is that? You have that formula, that is delta is equal to angle of incidence plus angle of emergence minus A. This emergent is nothing but I2 and I is equal to, here this is I1. I is equal to I1. Now here delta is equal to, if I write here, what will I get? I1 plus I2 minus A. That is delta is equal to I1 plus I2 mu R1 plus mu R2 minus A. So we have delta is equal to mu common, you can take R1 plus R2 minus A. Now what you get here? R1 plus R, we already know that A is equal to R1 plus R2. Now what you get here, delta is equal to mu times A minus A, that is delta is equal to mu of A minus 1. Means delta is deviation is depending upon the refractive index, deviation is depending upon the angle of prism, directly proportional directly. Raising emergence అని అంటున్నాడు. అంటే మీనింగ్ ఏంటంటే ఇక్కడ నాకు ఏదైనా ఇది నార్మల్, ఇది దీని మీద లైన్ ఇన్సిడెంట్ అయింది, ఇది ఏమవుతుంది గ్రేజింగ్ అవుతుంది, ఇది మీనింగ్. నార్మల్ ఇన్సిడెంట్స్, నార్మల్ ఇన్సిడెంట్స్ అండ్ గ్రేజింగ్, ఎమర్జెన్సీ అనేది గ్రేజింగ్ అవుతుంది ఇక్కడ. సో ఇక్కడ ఏం చేస్తుంది, దీని మీనింగ్ ఏంటంటే I1 అన్నది 0, R1 అన్నది 0. ఓకే క్లియర్. I1 అన్నది 0, I2 0. ఇది ఆ, ఎంత యాంగిల్ తోటి మీకు ఉంది, ఇది పర్పెండిక్యులర్ గా యాక్ట్ అవుతుంది కాబట్టి రిఫ్రాక్టివ్ ఇండెక్స్ అనేది R2 అన్నది 90 డిగ్రీస్, R2 అన్నది 90 డిగ్రీస్, R2 90 డిగ్రీస్ గ్రేజింగ్ అవుతుంది కాబట్టి R2 అన్నది క్రిటికల్ యాంగిల్ అవుతుంది, R2 అనేది క్రిటికల్ యాంగిల్ అవుతుంది. మరి ఇంకోటి ఏంటి, I1 0 అవుతుంది, R1 అనేది 0 అయింది, నో రిఫ్రాక్టివ్, R2 అనేది ఐసీ అయింది, కరెక్ట్ అయింది. నెక్స్ట్ ఏమవుతుంది, I2 అన్నది ఇది 90 డిగ్రీస్, అదే ఎమర్జెన్సీ 90 డిగ్రీస్. ఇప్పుడు మనం చూసుకున్నట్టయితే ఏమొస్తుంది, ఏ ఈజ్ ఈక్వల్ టు R1 ప్లస్ R2. సో ఫర్ ఏ ఈజ్ ఈక్వల్ టు ఐసి, ఏ ఈజ్ ఈక్వల్ టు ఐసి, R1 ప్లస్ R2 అంటే ఇక్కడ ఏమొస్తుంది 0 ప్లస్ ఐసి వస్తుంది. సో ఫర్ ఏజ్ ఈక్వల్ టు ఐసి. సో మనకి ఏ ఈజ్ ఈక్వల్ టు ఏమని రాసుకోవచ్చు, సైన్ ఇన్వర్స్ ఆఫ్ 1/μ1 కూడా రాసుకోవచ్చు. డెల్టా ఏమొస్తుంది, డెల్టా ఈజ్ ఈక్వల్ టు ఐ ప్లస్ ఈ మైనస్ ఏ. డెల్టా ఐ అనేది 0, ఎమర్జెన్సీ అనేది 90 మైనస్ ఏ అవుతుంది. క్లియర్, అంతే కదా, క్లియరా, క్లియర్. యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ లేదు, సెకండ్ సర్ఫేస్ కి డైరెక్ట్ గా నార్మల్ గా వస్తుందని చెప్తున్నాను, నార్మల్ ఇన్సిడెన్స్ అండ్ గ్రేజింగ్ ఎమర్జెన్స్, అది మెయిన్. క్లియర్, ఇక్కడ మీరు ఏం తెలుసుకుంటారు, గ్రేజింగ్ ఇన్సిడెంట్స్ అంటే ఇలానే ఇన్సిడెంట్ అవుతుంది, ఇది గ్రేజింగ్ ఇన్సిడెంట్స్, రిఫ్లెక్ట్ అయ్యి గ్రేజింగ్ ఎమర్జెన్స్. ఓకే, గ్రేజింగ్ ఇన్సిడెంట్స్ అండ్ గ్రేజింగ్ ఇలా ఇవి నార్మల్గా ఇన్సిడెంట్ ఉన్నప్పుడు ఇలా మీట్ అవుతాయి. ఇది థీటాసి, ఇది కూడా థీటాసి, ఎందుకంటే ఇది ఈక్వల్ కదా, థీటాసి అయితే ఇది కూడా తీసి. గ్రేజింగ్ ఇన్సిడెంట్స్ అని ఎప్పుడైతే క్రిటికల్ యాంగిల్ అన్నప్పుడే కదా, ఇక్కడ కూడా ఏమవుతుంది క్రిటికల్ యాంగిలే కదా. సో మనకి ఏ ఈజ్ ఈక్వల్ టు R1 ప్లస్ R2. Therefore A is equal to R1 plus R2 అంటే theta C plus theta C ఏమవుతుంది, A is equal to 2 theta C అవుతుంది, అంతే కదా, క్లియర్. నెక్స్ట్ ఇక్కడ ఇది 90 డిగ్రీస్, ఇది కూడా 90 డిగ్రీస్, అంటే I ఈజ్ ఈక్వల్ టు E ఈజ్ ఈక్వల్ టు 90 డిగ్రీస్. Therefore డెల్టా ఈజ్ ఈక్వల్ టు ఎంత వస్తుంది, I ప్లస్ E మైనస్ E. డెల్టా ఈజ్ ఈక్వల్ టు I ఎంత, I ఎంత 90, ఇది కూడా ఎమర్జెన్సీ 90 మైనస్ ఏ, మైనస్ ఏ, ఏ ఎంత 2 theta c. సో డెల్టా ఈజ్ ఈక్వల్ టు 180 మైనస్ 2c. వెరీ ఇంపార్టెంట్, క్లియర్. Dispersion concept is dispersion. So whenever this is a prism and a light, this is a white light is passed, then the light reflected on that, you will see that there will be 7 colors, like that one we are calling it as, first one we are saying that A, G, R. So what is that, this is the incident ray. Now the angle between the deviation of the red color and the inciting ray, this is the emergent ray. Emergent ray is red and this is the incident ray. The final angle between them, this is delta R we say. This is we say delta O, and this we say here delta yellow, and this one we say delta green, and this we say delta blue, and this we say delta indigo, and this we say delta violet. You can see that maximum deviation is for violet color. See the incident ray and the violet color, what you're seeing is the maximum deviation, right? The incident, what is the emerging out ray and the deviation, the incident ray angle, you're getting the maximum. So whenever a white light, when white light is passed through a prism, it constitutes into 7 colors. This is called dispersion. Okay, clear? Right? Now we have the other one, that is the angular dispersion. Angular dispersion means angular, it is we have the deviation of the from the maximum deviation to the minimum deviation, that is you are having delta V minus delta R, because delta V is the maximum, delta R is the minimum, so maximum minus minimum gives the angular dispersion of the colors. Okay, now we have general formula, that is just now we have read about it, that delta is a small angle, that is mu minus 1 into a. This is the formula, you have noted it now. Delta deviation is equal to a small angle mu minus 1 into a. So for delta v, can I write this is mu v minus 1 into a minus mu r minus 1 into a. So what you get here? Mu v into a minus mu r minus into minus plus a, plus mu r minus a, mu r into a, mu r into a plus a. So a get cancelled, you are having a is again common, a is what, mu v minus mu r, difference between the two refractive index, that is maximum refractive index minus minimum refractive index multiplied with the angle of prism. Here power, what is the dispersion power? So angular dispersion, the ratio of the angular dispersion to the mean of the color, mean angular dispersion, color mean color mean color is what? Mean color means average. So what is the average color you are having here? Yellow. From this side RO, from this side you're getting yellow is the mean color. So we already know angular dispersion formula is what? Delta V minus delta R. Mean color is delta Y. Okay, we already know that delta V minus delta R is what? A of mu V minus mu R. We know already delta Y is what? A of mu Y minus 1. Cancel, you are getting dispersion power is mu V minus mu R by mu yellow minus 1. So this is the answer.